Welcome to the Local Future Network. This is Aaron Wissner. I'm here live on the line with physician Milton Mills from Washington, D.C. Milton, how are you doing today?
I'm doing great, man.
Milton works as a critical care physician in an ICU in the Washington, D.C. area. He also lectures extensively on diet, nutrition, and human health. And today, he's here to share with us his perspective and his research and what he's learned about the natural diet for human beings. Milton, what is the natural diet for human beings?
The short answer is that we are designed by our anatomy and physiology to be strict plant eaters. And that may come as a shock to some people because, you know, growing up in school, we were all taught that we are quote unquote omnivores, meaning that we are supposed to eat a mixture of plant and animal food. But the fact is that when you look at natural omnivores, or what I call by design omnivores, such as bears and raccoons and animals within those families, what you see is that they have an anatomy and a physiology that allows them to number one, catch, kill, dismember animals, consume raw and rotting flesh without any problems whatsoever, as well as a limited variety of plant foods. Human beings don't have that at all. Now, it is true that we are behavioral omnivores, meaning that when you look at our behavior, unfortunately, many of us choose to include these animal foods in our diet because that's the way we were raised. I was raised that way. And we have been taught to think that it is natural and normal, but it is not natural and normal. And it causes all sorts of health problems, including the major chronic diseases that we see in Western countries. And it causes premature death. And it's why by the time most people turn 40, their body's starting to fall apart. And there are actually some very interesting reasons why I would say the science world got so off track in terms of trying to elucidate what the natural diet for humans is. And part of it was because when you look at the history of the development of Western science, it really started in the 18th, you can actually say if you include the invention of the microscope, as far back as the 17th century. But it was really the late 18th into 19th century, the late 1700s into the mid 1800s, when medicine and those who are medical practitioners really started to take a more science-based approach to trying to understand why people got sick and how to treat those diseases. Moreover, nutrition science really started to come into its own in the late 1800s into the early 1900s. And the reason I'm making this point is that you had these disciplines developing out of Western societies where meat eating was the norm. And as a result, people looked for reasons to buttress the practice of meat eating. And they assumed that meat eating was necessary because we all did it. But, you know, if we use that standard to judge what is appropriate for human behavior, we'll quickly come to the conclusion that it's appropriate to beat your wives, mistreat your kids, and enslave people who are weaker than you. Because all of those things are very common practices in human societies, but they're also reprehensible. and unnecessary. Then as nutrition science started to really advance, they made a major fundamental mistake in their understanding of what was healthy and necessary. And let me just stop off and stop right now and make an editorial comment, because I often say that because none of these early anthropologists or nutritionists were doctors, they did not understand the impact of what they were recommending. And if they had been doctors, they would have understood this can't be right, because it can't be right that the food that we're designed to eat should make us sick, which animal foods do. There is, I mean, the studies have shown, over and over, that there is a stepwise progression. The more animal food you eat, the more disease you see, and the shorter the lifespan. There's just no question that that's true. And if these people had understood that when they were coming up with their theories, they would have realized that human beings can't be omnivores, because, again, it doesn't make sense that something we're designed to eat should make us ill. So take a cat, for instance, which is a strict carnivore. If you try to force that cat to eat plant foods, you'll kill it. Now, I know there's some vegans out there right now who are screaming at their computer screen saying, well, I've got my pet on a vegan plant pet food. Yeah, those foods are specially designed in laboratories to give these animals all the nutrients they need from plant-based sources. But it's not in any way, form, or fashion what you would consider natural plant foods, if you understand what I'm saying. And I'm not saying it's not healthy, because yeah, you can so construct these plant foods that they do deliver all of the nutrients these animals need. But if you don't do that, if you don't go through this special process, you will kill the animal, because they are not designed to eat it. Or if you instead remove meat from their diet, they won't do well, because they need that for their physiology. Their physiology is adapted to it. There is nothing in any animal tissue or product that human beings need and that they cannot find a healthier source from a plant-based source. So another problem early on was that people began to look at our quote-unquote nearest relatives to try and extrapolate what a normal diet is for humans. So you will often hear people say, well, we have 99% DNA homology with chimps, and when you look at what chimps eat fruit and termites, and occasionally they'll kill a monkey and eat that. So, that justifies animal foods or meat eating. Well, not to disparage chimps, but you look at a chimp and you look at a human being, and these are clearly very different creatures. The big mistake that people made was just this assumption that, well, because there is a DNA similarity, that means that our diet has to be similar. Human beings are different from any other primate species, because primates, by and large, are arboreal, that is tree-dwelling species, all of them. And even the ones that will go out on the ground, they only do so to a limited degree, and they always make sure that they are near enough to the trees that if something happens, they can go scuttling up a tree and get out of danger. Human beings are completely different. We have clearly left the trees and a tree dwelling existence, And we are adapted for living on the savanna, which is different from any other primate. So to look at chimps and try and say, well, our diet should be like their diet would be the equivalent of looking at a rat and a squirrel, which are both rodents, and saying they should have similar diets. No, the squirrel is a tree-dwelling species. Rats, live out pretty much would be a savanna or whatever. I mean, and they eat very different foods. And likewise, we were talking about this yesterday, that number one, chimpanzees are much smaller than human beings. They're like a half to 2/3 the size of an adult human. Number two, their diet is primarily a fruit-based diet. And again, if you know anything about fruit, you know that fruit tends to be relatively low in its protein content. So that is why for a species like chimps, they may need to, from time to time, supplement their fruit-based diet with some termites and ants to get that added protein that they need. But human beings don't need to do that. Well, how do I know that? It's because human beings are designed to be, well, there's again, I mentioned this paper by this scientist, Clifford Jolly, who argued that what really allowed hominids to differentiate themselves from the tree-dwelling primates and to really become successful and prosper and expand was moving out onto the savanna and taking advantage of seeds and legumes and tuberous vegetables. And seeds are extremely high in protein, they have a lot of protein. And so if you're eating grains and legumes, and even root vegetables are relatively have a significant amount of like tubers, like potatoes and sweet potatoes, yams, and so forth, have a significant amount of protein. Then we don't need to supplement our diet with any kind of animal protein, because we're getting more than enough protein from the foods that we're eating. And it turns out that the protein that we're getting is much healthier for our physiology. So let me get back to something I alluded to earlier about what was screwed up about the way nutrition dogma developed. Again, probably everybody has heard at some point that animal protein is a higher quality than plant protein. Where did this mistaken notion come from? Well, early on, because our ability to analyze various plant tissues and so forth was not very sophisticated, early nutrition researchers thought that plant proteins were incomplete, that plant protein sources were missing certain essential amino acids. Well, that lie, that myth, that canard has been put to rest. All plant foods have all of the amino acids that we need, both essential and non-essential. All right, number one. But what is different, and I'm going to pull something up that I hope you'll be able to see.
Yeah, and at some point, I think it would be. I mean, I've got a lot of questions, so I mean,
okay.
I love.
All right, I'll finish this point and then I'll let you jump in.
Okay.
Let me ask you something. All right. Can you see? Let's see.
Yeah, I can see it a little bit.
Okay. All right. Well, the pictures are reversed, but So
No, it
what?
looks good to me. So it looks like
Okay, all right.
it's a
So
bar
this is
chart, and it's
this is
slowly
a
coming up.
chart showing the leucine content of commonly eaten items. Okay, the thing I want you to pay attention to is how much more leucine is in animal products versus plant foods. There is enough leucine in the plant foods to keep us healthy, but not so much that they will turn on these growth genes called mTOR. TOR stands for target rapamycin. Then I won't go into the derivation of that. But the bottom line is that when you eat foods that have a very high leucine content, it turns on growth genes. Well, that's wonderful if you are a baby or toddler, which is why dairy products have a lot of leucine. Because when a baby is nursing from its mother, it should be getting a lot of leucine so that it will tell its body, create more cells, keep those cells around so that the baby will grow and get bigger. But as an adult human, we should not be turning on growth genes because our bodies can't grow. And what ultimately happens is that constant signal to grow that's coming from things like dairy and eggs and meat, beef, poultry, and fish and so forth, is that it causes those cells to start to grow tumors. Now, not all of the tumors are cancerous. Many of them are benign. And that's why people have moles and skin tags, and women get cysts in their breast and uterus. Men, our prostate swells up to the size of New Jersey. Everybody has these lipomas sticking out of their body because that comes from this abnormal growth signals that our cells are receiving from these foods that we're eating. But in many cases, unfortunately, it does cause those cells to become cancerous. And if that cancer cell escapes detection from the immune system, then it will grow into a tumor and suddenly a person is diagnosed with cancer. And that is why, again, people, all of the studies show that eating animal flesh is associated with a higher risk of developing cancer over your lifetime, not just cancer, but heart disease, stroke, and so on. And I'm going to say one last thing, and then I'm going to let you jump in with all your questions. I want everybody that's listening to this to assume that I am the Black version of Kellyanne Conway, that I'm sitting up here making all this stuff up, and research it for yourself. Because when you do the actual research and you see how much data there is supporting what I'm telling you, that will help convince people that they need to change their diet.
All right. So that's a lot.
Yeah.
So for those of you who are viewing, Milton and I had this chat on the phone yesterday.
Yeah.
And it was more conversational, but I think we can recapture a lot of it, because I mean, my questions, based on science and history and everything, we know that, starting from singular cellular life back 3, 2, 4 billion years ago or whatever, now there's this huge array of multicellular life on Earth. It's all around us. It's everywhere. There's still all this singular cell life and everything. And if you go back, to the a million years, 2, 3, 4, 5, 6, 7, 8 million years from when humans diverged from the other great apes, where we have our nearest common ancestor, that our bodies have changed. And you've pointed out that when our ancestors were no longer, when they started to see, I mean, what happened? They were tree dwellers at some point. They must have been similar to chimps or orangs or gorillas. They must have been similar, but something but the ancestor, I mean, they all that.
Sure.
So what happened? because, but even then, they would have been primarily, I mean, almost 100% plant eaters, right? Fruit eaters.
Absolutely.
And
Absolutely.
just kind of opportunistic. They wouldn't necessarily be chasing down a gazelle or chasing down.
We can't chase down a gazelle. Without technology, we cannot hunt, period. So until humans became smart enough to actually invent the technology that allowed our bodies to do what nature never intended them to do, there was no hunting. And some anthropologists said, well, okay, yeah, that's true. So we probably scavenge. I'm like, are you crazy? Every Thanksgiving, the emergency rooms are filled with people who have food poisoning from eating poorly cooked turkey that they cooked in a range that cost them over $1,000, and they still couldn't get it right. And they come in with, if they aren't treated, life-threatening illnesses. Well, you go around eating rotting tissue on the savannah, you're gonna be dead. Because there are no doctors, there are no antibiotics, there's no IV fluid, and we don't have the physiology to handle carrion, period.
So you're saying the ones who a long time ago, who might have had this inkling that, hey, that looks like food, why don't I eat it? They probably didn't end up living to reproductive age, did they?
No, they didn't. None of their progeny are around. And again, another way you can know that is that when you watch carnivores in the natural setting, if they smell a rotting carcass, they are on it like what they say, white on rice, okay? Because that's food for them. And they have both the stomach acid and the robust immune system that allows them to eat pathogen-laden, rotting tissue and not get sick.
Well, in what way is their stomach different? I mean, are they able to like kill the bacteria that's on that rotting meat, or what?
Yes,
I mean,
yes.
Really?
Carnivores have incredibly powerful immune systems that can somehow, well, number one, one of the biggest differences is in the amount of acid that they secrete. When you eat let's say you eat a big meal, you go to your mom's house, it's your birthday, she says, oh, honey, I'm gonna fix all your favorite foods that are all vegan. And you eat till you can't eat anymore. Once your stomach is full of food, if I dropped a pH meter down into your stomach to measure the pH, it would be about 4.5 to 5, okay? And for
so
those
acidic, but not really strongly acidic.
No, exactly. Weakly acidic. And it's strong enough to kill the kind of pathogens that are typically found on plant foods that haven't been contaminated with, animal effluent, but certainly not strong enough to kill the kind of pathogenic organisms that are in animal tissue. I mean, that's one of the reasons we're dealing with COVID right now. But again, that's also why we see people getting salmonella, shigella, campylobacter, E. coli food poisoning, because we don't have the physiology to kill those things. When a carnivore has a full stomach, and let me just say that they have gigantic stomachs. They can eat 30% of their body weight at a single meal.
30%. So
yes.
that for me would be like 50 pounds.
Exactly. And again, this is a key difference between carnivores and herbivores. Hunting, even for the best carnivores, is still inefficient. And they typically make a kill every 7 to 10 days. So they have to be able to ingest enough calories at one sitting that will make up for all the animals they chased and didn't catch, replete their body, and still give them enough calories to last until they make another kill. Whereas plant eaters, because plant foods have cellulose or fiber in them, plant foods require a lot of processing to be able to extract the nutrients from it. So all plant eaters have much smaller stomachs, and they're batch feeders. And they have to eat 2 or more times a day just to get enough calories to last them one day. That's a major difference between carnivores. herbivores. No human being, unless they are literally drinking pure oil, and they'll pay for that later, can consume enough calories at a single meal to last them even a day. We, like all plant eaters, we have to eat multiple times a day. But did that answer the questions that you?
Well,
Because I've got so many things rolling through my mind that I want to talk about too.
Well, I think that's good. I think we want to get back to the savannah, but I mean, another thing that's jumping to mind is that I don't know if you know of a guy named Hawking, Stephen Hawking.
Oh yeah.
And he's an astrophysicist, a cosmologist who
I know who he is.
Yeah.
I know exactly who he is.
Well, he had a way of, like, in order to understand something, you just kind of have to think about it with the evidence that you have in front of you just at this moment. So, for example, we kind of know what our body is like. And I mean, we know what our body is like. And we know that our body evolved or was created in this way, whatever belief system we have as far as the background. And our teeth these are the teeth that we have. You know, I don't see fangs.
Exactly.
I mean, our teeth don't look like the teeth. I mean, they're similar to the teeth of the gorilla and the orangutan and the chimpanzee, but they're not the same. I mean, they don't even have like our carnivore teeth, our canines have been
right.
So, I mean, we can look at our teeth, we can look at our stomachs like you're saying, and we can kind of figure it out what food our ancestors must have been eating, right?
Exactly. I'm listening to you. There's something else I want to show you. Just keep talking, Aaron. I'm listening to you.
Okay. So what I always think of is, when did the evolution of the human body kind of end? Because our bones and bone structure and everything has been so similar for the past 100,000, 500,000 years, almost a million years. I mean, there's been some divergence with the Neanderthals versus Homo sapiens, but it's been very, very similar. And with the Neanderthals, who lived in northern climates, very northern climates primarily, and my understanding is they were the early ones to put on clothes because of winter, skins.
And they're believed to have eaten a more meat-based diet.
Which contributed to the fact that their evolutionary line had larger jaws and had stronger muscles right here. They were the ones who were the last ones to be, that we find in the fossil record. So their mouths and heads were evolving in the direction of, well, we have to eat meat half of the year or a third of the year. When it's winter time, we can eat everything else the rest of the time. Whereas
I would argue that that's not really the case.
Okay, go ahead.
Yeah, they did have more robust. Oh shoot, I'm sorry.
That's okay.
A more robust jaw structure, but this is what I want to show you, and you'll understand what I mean.
Okay.
All right, do you see these? Can you see these well?
Yeah, lift it up. Go ahead.
Okay. Does that make it better?
Yeah.
What you can see is from this is that damn. Why is
that's good. That's good.
Okay. Humans and horses have a jaw joint that is above the plane of their cheek teeth. Okay. See, the jaw joint is up here, teeth are down here. And we also have this area called the angle of the mandible that's expanded. And I'm sorry, you can see this a little better in horses as well. Whereas carnivores, the jaw joint is on the same plane as the cheek teeth, and it allows the jaw, the upper and lower jaw, to act like a pair of shears, which is what allows them to slice meat off bones, crack bones in half, and so on and so forth. This type of above the plane of the cheek teeth jaw joint is something that is exclusive to committed plant eaters. Because when you look at, I talked about by design omnivores earlier, bears and raccoons still retain this type of jaw joint, because if they're going to be attacking and killing animals, they have to have a very stable jaw. Otherwise, they'll dislocate their jaw and starve to death. Moreover, they still have to be able to slice the meat off the bone, cut through hides, and so forth. You can't adopt that above the plane of the cheek teeth jaw joint until you have given up meat eating and committed to a diet of plant foods, because that L-shaped lower jaw, which is what the above the plane of the teeth jaw joint gives you, is much more mobile, and it allows you to perform the grinding actions that are necessary to disrupt plant tissues so you can get at the nutrients that are contained in the plant foods. You don't need that if you're eating animal foods, but you absolutely have to have it if you're eating plant foods, because imagine if you...
So Milton, would this have happened back evolutionarily when our way distant ancestors, say 100 million years ago, when they started going into the trees and eating fruits? I mean, would that be the point where they were getting so much of their food from the fruits that the ones that had, you know, mutations that made
Sure.
them more able to eat? And I mean, is that the point? I mean, is that far
right
back?
and exactly, and and as far back as you can look in the hominid human line, all of our putative ancestors have that above the plane of the cheek teeth jaw joint. They have the flattened nodular molars. They clearly have a jaw that is designed for grinding up plant foods. Now, some of the earlier creatures that are thought to have been human ancestors, they had more robust jaws than we do, but they also had much smaller brains. And it's thought that they were eating essentially a lot of more roughage and leaves and so forth, which require a lot more processing.
So is that the Neanderthal angle then?
To an extent, yeah. What sort of characterized human beings and the line that led to humans is that there are, I mean, you could probably, without even trying, name 10 to 15 monkey ape species right off the top of your head. That meant that there was a heck of a lot of competition up in those trees for food sources. People also have to keep in mind that the ecology of the earth was changing at this while all this is going on, and suddenly you had the development of grasses and the radiation of grasses as plant species, and you have all of these grasses out on the savanna that, you know, at least once a year, maybe more, produce these huge seed heads that have all of these edible seeds.
You know what you're implying? You're implying that our ancestors were not as successful in the branches as our cousins in the branches. And so since we were less successful, we ended up on the ground looking for food maybe. And then our line went in that direction?
I would phrase it differently.
Okay.
Aaron. I would say that our ancestors were smart enough to look at this unexploited food source and said, the heck with fighting you guys for these figs. I'm going out here and get all this food that's just laying around to be grabbed. You know, it's like somebody that's, you know, working in a factory and they discover, you know, gold, you know, somewhere, and you know, a lot of people say, oh, I'm just going to stay on this job. And the other one's like, the heck with that. I'm going to pick up some of this gold. So that's what, and that's also an important point, because it is the exploitation of these novel food sources that was really responsible for the expansion of the human brain, because we had to learn and begin to understand a lot of things about flowering plants in order to be able to exploit these new food sources. So number one, the first thing we had to learn was the dynamic between a flower and the eventual food it produces. And then we had to develop a sense of time, because it would do you no good to see a flower and come back the next day looking for food. It's not going to be there. You got to, realize, no, it's going to take about 90 days for that food to fully develop. And then you also realize I got to be back on time, because if I don't, the antelope or the wildebeest or, some other savanna dwelling creature is probably going to eat all this stuff. And all of these things take computational power. I mentioned to you that I have a lecture called Flowers and the Human Intellect. And in that lecture, I actually argue that understanding our relationship to flowering plants solves one of the great mysteries about human beings. And that is, how did we develop language? And why did we develop language? And language is fundamentally using a sound to represent an object, right?
Sure.
Well, that's exactly what a flower, the relationship of a flower to its fruit. And I think that once we understood that, a peach blossom would eventually give you a peach, it taught us that you could use, a different sound, a different object to represent something else. Now, that's my belief, but, we'll have to see.
That's an interesting, I'd love to get Noam Chomsky's or another evolutionary linguist's insight on that as well.
Yeah, no, absolutely. And because none of these other theories, in my opinion, make any sense. But again, when you start to understand the relationship between a symbol and an eventual object, that is the fundamental part of language. And I know something that's something else that's interesting. There's really only one other species on this planet that has a complex language that they can apply to novel situations. And it's bees. The waggle dance, where they find a food source and they're able to come back and use this dance language to tell the other bees where in the environment to find this particular food source. So they are in essence using a stable lexicon to describe novel situations. That's language. And the waggle dance is absolutely a language. And it's fundamentally different from animals that have, innate sounds that they utter to, as warnings or scoldings or as, come join me. This is actually using a specific suite of, in the case of bees, behaviors to put those things together in novel ways to describe a novel situation, which is what we do with language all the time.
So this reminds me of great apes fascinate me for their behaviors and how they raise their young and things like that. So I've watched a number of documentaries and read books on them. And one of the behaviors, one of the languages, I was reading about chimpanzee language, and it is a very immediate sort of language, like come with me,
right,
scratch my back. I mean, I don't remember in any of the language descriptions the chimps being able to explain to each other, I need you to go such and such a place.
Exactly.
I mean, the follow me, yeah, you can follow me. There's the follow me motion, right, but it's not really quite that abstracted.
Right, and they can't say to a chimp, hey, I got this banana from the group of trees that's, over around the bend. They can't do that. And I just find it interesting that it's two species whose entire development was dependent on flowering plants that developed actual language. Now, I would have to turn that over to an actual linguist to have them sort of play with the ideas and develop it. But it's something I noticed.
That is really interesting. So let's go back to what our ancestors were
Sure.
eating, our ancient ancestors.
So
So when we were in the trees, we were eating mostly fruits, right?
Right.
What else? I mean, we might have went down and ate
fruits,
some
nuts, and maybe in leaves.
Okay, and we were living off that. I mean,
Sure,
that was adequate for us at that time.
But we were
our
much
ancestors.
smaller.
Okay, right.
Much smaller. That's the other thing, that switching to this savanna plant-based existence allowed us to become much larger.
Are you sure we weren't chasing after the gazelles with our sharp teeth?
Well, you know, that brings up my theory about our ability to run. First of all, we can't chase anything down. We're not fast enough, nor do we have the stamina to do it.
Wait a second. What about those folks in Namibia, the native hunters, that they will follow the gazelle for like 30 miles and they just keep following it until the gazelle or whatever, wildebeest, whatever,
drops dead.
It drops.
Well,
it drops.
Actually, what they do is they wound it first, and then they follow it until it finally dies from exhaustion.
Right. So this would have been after the advent of projectile weapons then.
Right. But that is the equivalent of a $20,000 wedding dress. What do I mean by that? Women go out and spend huge sums of money on these big white poofy dresses that they wear for one day because it serves a cultural purpose. Okay, it's a value we've embraced. There's no practical value to that dress. That dress is not bulletproof. It doesn't make you live longer, doesn't make you more fertile, and it certainly doesn't make all your friends and family forget the fact that you lived with 2 or 3 other dudes before you got married. So,
well, thanks for that image, Milton.
But it's something that we do because we've embraced it as a cultural value. There is no species on this planet that either exists or has ever existed that tries to hunt by running prey to exhaustion. Why? Because it's a losing proposition. In nature, you always have to be able to extract more energy from the food that you get than you expend than the amount of energy you expended getting that food. You follow me? It's a function of energy out versus energy in. So, well,
again, it's saying that our cousins, not our ancestors, but our cousins way back who decided they were going to try this, they didn't live to reproductive age either.
They couldn't have. And the only reason these guys are able to go out and do such an extravagant waste of energy, like chasing an animal for 20 to 30 miles, is because the women are back home getting the real food. Because they will not be able to extract enough energy from that single animal to make up for all the calories they spent chasing it for 20 miles. So they will still be in an energy sink. And the only reason they can get away with that is because the women have gathered enough plant foods to see them through the night and the next day.
Okay, so let's go back to our ancestors that decided, hey, this grass is not bad.
There's a lot of food out here on the savannah, and nobody's out here getting it. It's like we got it all to ourselves.
And so what sort of things entered the human diet and started, now there's going to be some evolutionary pressure right at this point, because now what is being consumed, there's going to be some kids being born.
Yes. I'm sorry, man. I know I'm cutting you off, but I got to tell you this. So what kind of adaptation did we make? Human beings have 6 times more starch digesting enzymes genes than any other primate. So the adaptation we did physiologically was to become better able to digest starch efficiently and fully.
So starch as in seeds or tubers?
No, starch as in
what kind of foods are you talking
glucose.
What kind of foods are you talking about? What are we eating?
Well, grains have a significant amount of starch. Legumes and tubers have a significant amount of starch. Root vegetables, all the things that we commonly eat are loaded with starch. And why should we need starch? Well, we have a gigantic computer sitting on the top of our neck that uses nothing but sugar for its metabolism, its energy metabolism. And starch is nothing but long chains of sugar molecules.
So our brain doesn't use proteins or fats or alcohols?
I mean, if it has to do some kind of repair, alcohol actually kills neurons. But no, your brain runs on pure glucose. In fact, every single day, 25% of the energy that you burn is burned by your brain alone. The human brain accounts for only 3% of our body weight, but uses up 25% of the energy we burn every single day. And that is essentially in the form of sugar, glucose. The only thing the brain would normally use proteins or fats for would be if it had some repair work to do, or was increasing the size or numbers of neurons, or is making neurotransmitters. But in terms of its energy metabolism, pure sugar. And if you've ever seen someone having a hypoglycemic reaction, meaning that the amount of sugar in their blood gets too low, they go into a stupor. Our brain cannot function without sugar. And that's why we had to.
But not refined sugar that's
granulated. No, right, yes, not refined. That's a different topic, but we are talking about natural fiber-containing whole plant foods. Those are the ones that are healthy, not soda pop and potato chips and all that stuff. You probably heard me say this at one of my lectures before. I tell people that white flour, white rice, white sugar, those are all refined products, and we should try and avoid them. So my sort of glib statement is, I tell people the only white things at your dinner table should be the tablecloth and the people eating dinner. Everything else should have some color. Much healthier for us.
All right. So our ancestors were in the trees. They went down on the savannah. They started eating all these other plant foods. And so now we're eating almost all the plant foods, except like the barks. We aren't eating that. And we're not.
No.
But then at some point, fire, right? And at some point, projectile weapons or traps.
Sure.
And so what happened then? Didn't we become carnivores? Didn't we become omnivores, at least at that point? Wasn't there evolutionary pressure to make us didn't it change our teeth and change our stomachs? And
absolutely not.
Aren't we now carnivores, or at least actual omnivores?
Have we adapted to a diet that contains meat? And the answer is no, and no. I tell people you can put a pig on a plane and make it fly through the air 600 miles an hour, but that does not mean it's meant to fly or it's designed to fly. The only way it can do that is with technology. And the minute we start to use technology to do what our body does not allow us to do, then natural selection ceases to be a factor in what happens to us. So that's why, to this day, we've got to have a knife and fork to cut up animal tissue. Otherwise, we're going to choke to death on it. That's why we have to have spears and other things to try and kill these animals, because we don't have the natural physical equipment to do it. And because we use our technology to do that, then there's no selection pressure on us to develop claws or to develop, to become much faster than we are so we can actually chase things down, or to develop the kind of dentition that allows us to dismember animals. So yeah, technology invented by Homo sapiens sapiens and maybe Cro-Magnons caused our bodies to stop changing, because they didn't have to, because we had technology to do what our physiology and anatomy didn't let us do.
So there's not really been a lot of evolutionary pressure on the human species, the Homo sapiens, Homo sapiens
Right.
species, or Homo sapiens sapiens species,
Yeah.
since the advent of technology like throwing weapons
Exactly.
and fire, especially
Exactly.
fire. I mean,
Exactly.
can you can you can you just give me your perspective on the
Sure.
advent of fire and how that changed stuff for our ancestors?
So, I mean, fire serves a number of different purposes. One, it helps to scare off potentially threatening animals. Two, we clearly are diurnal creatures, meaning meant to move around in the daytime because we have lousy night vision. Fire helps us to see better at night. But it also helps us to process foods, plant foods, in ways that makes them more digestible. Uh, but it also changes the taste and flavor of those plant foods. And people have suggested that fire was used or utilized by human beings to make meat eating permissible, meaning that everybody realizes that animal tissues are frequently laden with pathogens, and if you let them sit out for more than a couple of hours after the animals died, they start to rot and to break down and create lots of toxic compounds.
This reminds
And
me of the whole sense of this instinct for disgust.
right, yeah.
What is disgusting? And it's like a real thing. It's like an evolutionary thing,
It's an
right?
evolution. Yeah, disgust is something we're hardwired for. We're born with that. It's not I mean, of course, we can learn to be disgusted by certain things like orange idiots in the White House, but um, I got to get my dig in there.
We'll give you that one, Milton.
But no, we are, and for your listeners, I have a lecture that covers this in great detail. It's called Meat Eating and Mind Games, and it talks about how how we have to change the way animal tissue looks, tastes, and smells in order to make it acceptable to our brain to circumvent our disgust response. And that's why we cover it with all these plant products we call seasonings, because we're actually trying to make it taste like what our brain really wants, which are plant foods. So yeah, it's the movement onto the savannah opened up huge food resources that certainly other primates were not exploiting. But the question is, how did we know what was edible and what we could eat? It's because we looked for plants that were flowering plants. Because again, we learned to recognize the fact that if you have a flower, eventually you will get some food. So when we're walking through the savannah and we see a squash flower, it looks like it's just a flower on a vine. But again, associative property of mathematics. If A is equal to B and B is equal to C, then A equals C. So it was very easy for our ancestors to say, hey, wait a minute. A fig blossom eventually gives me a fig. I'm gonna come back in a couple of weeks and see what's grown here and see if it's edible. And that is what allowed us to become the most successful mammalian species on the planet. Our adaptability and our ability to recognize these relationships between flowers and eventual food. And that also explains why we as a species love flowers, which otherwise shouldn't make very much sense. And this came home to me in a very stark and funny way several years ago. It's actually why I eventually developed that lecture, Flowers in Human Intellect. I was out walking my dog. Dog had a black lab at the time. And we came across some irises. Now, I just think irises are so beautiful. And I stopped and I was, having my emotional moment, admiring the irises. And Onyx, my dog, went up, sniffed them, and peed on them. and that's what started me to thinking about our different emotional responses to these flowers. That for me, it was truly an emotional experience. To her, it was just something else to mark her territory with.
Are you saying, Milton, that you didn't have an urge to pee on those flowers?
I did not. I absolutely did not. I had an urge to pluck them and take them back home, but I don't do that. I think it's much, in many cases, and certainly when you see things in the wild, it's better to leave them in place, admire and enjoy them, and then leave it for someone else. But the important point, again, for people to realize is that beauty, the concept of beauty, is a biological concept. That the reason we as humans find certain things beautiful, certainly if you look at what we find beautiful in each other in terms of the sexes, these are physical attributes that correlate with improved survival, and that make us more fit and more likely to be healthy and have healthy offspring. So then the question obviously is, well, why should we find flowers beautiful? Because flowers are precursors of food. So by learning to be attracted, or basically, there were undoubtedly some idiot hominids that peed on the flowers and starved to death. Those who learn to be attracted to them, to find them beautiful, to seek them out in the environment, were able to exploit a much wider range of food sources because of their ability to recognize that relationship and their attraction to these flowers.
So I'm imagining one of our ancestors far, far back, and she's looking out on the savannah, and she sees some flowers over here, and she goes, looks at them, and she's like, oh, those are nice. And she sees some over there, and she goes, looks at them, and she's like, yeah, these are going to grow into something. And then she comes back, a month or two later, and she's like, hey, wow, that I remember this one was like yellow, and this one was like reddish, and this one was, and then she shows her family and her kids, and the ones that are able to remember that are also our ancestors. And the ones that didn't remember it are not our ancestors.
We don't know who they are. And let me share this quote with you. This is from my lecture on flowers. Okay. This is by a neuroscientist from Harvard by the name of Steven Pinker. And basically what he says was, natural selection was bound to favor those among our ancestors who noticed flowers and had a gift for botanizing, for recognizing plants, classifying them, and then remembering where they grow. In time, the moment of recognition, much like the quickening, would become pleasurable and the signifying thing, a thing of beauty. This is by Steven Pinker in his book, How the Mind Works.
So remind me, the quickening, that's not a term that we use very often.
That's when a pregnant woman first feels her baby move.
Okay.
That was called the quickening. There are a lot of spurious theories out arguing that it was meat eating that spurred the development of human brain development, which is just flat out idiotic for so many reasons. Number one, there's nothing in animal tissue that is directly trophic for the brain.
What do you mean by trophic?
In other words, it's not like eating meat makes the brain either grow bigger or function better. Trophic meaning having a beneficial effect on the physiology. Meat is protein. The brain is mostly fatty tissue with some protein scaffolding, but once you develop the brain, it's like building a computer. You don't need somebody to keep bringing you microchips. You just need the electricity to make that thing run. And likewise, when our brains are developed, we don't need the raw materials that build brains. We need the fuel to fuel that brain, and that directly comes from plant foods. Furthermore, It's really absurd for people to talk about how important meat eating was in human development because our bodies cannot store protein. So every bit of
What about our
protein.
muscle? Look at these guns right here. What about these muscles? Isn't
Well,
that
I
storing
mean, if you're
protein right there?
building, I mean, yeah, I mean, if you're building tissue, right. But all right, now you got some nice arms. You look pretty physically fit. At this point, your body is in homeostasis mode. In other words, just maintaining. So if you eat a kilogram of protein today, your body is going to take a very small part of that protein, use it to replace tissues that need to be repaired, make some neurotransmitters. Everything else is going to be converted into carbohydrate. And that nitrogen, which is what makes protein, is going to come out in your urine and your feces. Our bodies do not store protein. They cannot store protein. So there is truly no advantage to eating huge amounts of protein.
Okay, so this brings me to what I think is a really relevant point. So a protein molecule is a super long, these super long molecules, and there's all sorts of different ones, right?
Right, made up of amino acids, yeah.
But they are themselves made out of amino acids.
Right.
And so this glucose that our brains is using, is that an amino acid or is
Nope.
that, what is it? Oh, but that's different, isn't it? But
yeah, it's a carbohydrate.
But the point is, does our body actually use the full protein molecule if we get one in our stomach, or does it break it into amino acids?
No, all proteins are broken down into their individual amino acids.
So it would make more sense to eat the plants because it's already amino acids.
Well, I mean, so plant proteins and animal proteins are long chains of amino acids that are joined together to form whatever the plant or the animal wants to form. The reason why it's healthier to eat plant proteins is because, one, they come in a package that has antioxidants, phytochemicals, fiber, which is super important, and we don't have time to go into that, and they don't contain animal fat, which is very toxic to our system. Moreover, the reason early nutritionists thought that, and that goes back to that chart I showed you, that animal proteins had quote unquote higher quality, was because the animal proteins have higher amounts of of certain essential amino acids, the one that our bodies can't make. And so these nutrition researchers took the more is better approach, and they said, well, since the animal proteins have more essential amino acids, that means they're high quality.
Well, how's it possible that you're looking so good after 20 years of having no animal products?
Actually, it's been 40 years, and I'm only admitting the 40 years.
Well, and I've been vegan for 18 years, but shouldn't I be dead by now if I haven't eaten any animal products?
Absolutely. And so it's just nutrition science got it completely backwards. That the more amino acids, essential amino acids you have, the more you're going to turn on these growth genes, the more IGF-1 or insulin-like growth factor hormones you're going to, your liver's going to manufacture, and all of those things are going to promote tumor development and cancer development.
Now, now this is a question I've often wondered about. Are wild animals susceptible to a lot of cancer?
Yeah, actually. And you know, again, another common question I ask audiences that I speak to is I show them a picture of an elephant, of a cow, and of a rhino. And I say, what is the natural diet for these animals? And they say plants, which is true. Then I ask, what is the only time in their life when they eat animal protein? It's when they're babies, when they're nursing. And that's because those animal proteins turn on those growth genes, which is exactly what you want in an infant. But you don't want that in an adult. And it's really that simple, but that profound. That is one of the major reasons animal proteins promote the development of cancer and heart disease and diabetes, which are basically diseases of metabolic dysregulation.
So stepping back to the now, if there's, suppose you have a patient, a client, a friend, someone who you're talking to about their nutrition, and they're eating the standard American diet.
Sure.
And you say, well, and they don't care. They don't care about.
Right. They say, so what?
They don't care about, well, that's not what I'm going to say.
Oh.
They don't care about evolution. They don't care about animal issues. They don't care about environmentalism. They don't care about any of that stuff. What do you say to them as far as health? I mean, in what way is this better for me, Dr. Mills? Dr. Mills, why is it better for me to eat a plant-based, whole food, plant-based, SOS-free, whatever it is that you want to call it, diet? I mean, what's in it for me, buddy?
Exactly. What's in it for you is better health, lower disease risk, improved longevity, and a lower risk for dementia. The fact is that we cannot escape our physiology. We can escape our anatomy through technology, but we can't escape our physiology. Because once we actually ingest a particular item, it's either going to create health or it's going to create disease. And whether we like it or not, our body is designed to handle plant foods. It's like taking a car that's meant to run on gasoline and putting diesel in the tank, or vice versa. You might say, well, the diesel's cheaper this week, so I'm going to just load it up with diesel. Well, if you do, you're going to screw up your engine because it's not designed to burn that fuel. And the same thing happens to our bodies, that these foods basically damage our genes little by little. Now, the human body is an amazing organism, and it has a lot of repair mechanisms, but essentially after about 20 years of abuse, 20 to 30 years of let's say 30 to 40 years of abuse, starts to break down. And that's why, people start to get all of these chronic diseases as they move to their late 30s into their 40s, and their skin starts to wrinkle because of all the oxidative stress, and they start to look old because they are aging their bodies prematurely. And yeah, it's like I hardly ever tell anybody how old I am because, people's jaw drops. They're like, you got to be kidding. I'm like, no, I'd like to think it was a computer
Well, you look
error.
like you're 55 or 60.
That's about the ballpark. Yeah.
Okay.
Yeah. And I'm actually a little older, but yeah. But it's and I mean, I look at people I grew up with who are not plant-based, and I'm telling you, man, they look much older. They have way more health problems. They're just, you can see the wear and tear on their bodies. So it comes from a lifetime of the wrong foods.
So again, here we are, April 22nd of 2020. And I think I want us to wrap around two last things. So there's a few food items that I'm really curious about, and maybe I'll go to that first. So here's some food items. You've hit meat a lot. And I imagine fish kind of and poultry goes into this.
That's all animal tissue. Yeah, exactly. When I say meat, I mean all animal tissue.
Okay, but let's go to some other things. So we've got eggs, we've got honey, we've got milk, we've got worms and grubs and things like that, which I know is not part of the standard American diet, but
still animal tissue.
I can imagine our human ancestors eating those maybe, and like the bugs and termites and stuff. So can you address any of those or some of those?
Well, sure. I mean, I can definitely give you my, I think, informed opinion on them. So, human beings can become inured to used to, less affected by almost anything through constant exposure or being taught to do something. It actually turns out that early taste test studies that were done on human babies showed that across the board, human babies do not like the taste of animal flesh until their parents, essentially by repetitive teaching, force them to eat it. And then they develop a taste for it. human beings, by and large, are squeamish around insects. And we don't like bugs. We don't like them crawling on us. We don't like them in our homes. And I would argue that that is because our brains don't want to eat bugs. Now, yeah, we can learn to eat bugs, and there's plenty of cultures around the world that have learned to incorporate crickets and other things in their diet.
This reminds me of there was this TV show used to be on, and maybe it's still on, called Survivor, and they would have this challenge where you had a plate of bugs or something and you had to eat it, but the disgust came up. So yeah, I'm seeing the point where humans probably never were big on eating bugs.
And actually, you know what else points to that, Aaron, is the amount of hair that we have on our bodies. Because clearly we do not have either enough hair or the right kind of hair to keep us warm. So why is it there? So let us know when something's crawling on us. That's really what these hairs we have on our body, I mean, do for us. They let us know when something that could potentially bite us and give us some sort of, disease or harm is actually crawling on our body. Because otherwise, I mean, our skin could be completely naked or hairless, would be a better word. And it would make no difference to our functioning and physiology. You understand my point?
Sure.
So yeah, the only reason and let me also say, the reason we jettison the hair that the other monkeys and apes have is because our skin is actually a giant radiator for our brain. The brain, as I said, is the most metabolically active tissue in the body. 3% of your body burns 25% of your energy every 24 hours. That's a huge amount of huge metabolic rate. Your brain uses 20% of the cardiac output, 20% of the body's oxygen. The human brain is, just working at a phenomenal level, and it generates tons of heat. Well, heat doesn't radiate across bone. So like a car's engine, the only way to get rid of all this heat that our brain is continually producing is to send blood through the brain, pick up that heat, and then bring it out to the skin and radiate it out into the environment. And that's why we had to lose our hair. But the question is, why didn't we lose all of it? Well, because again, we need to know if something's crawling on us. And that can be done much more efficiently if it's tripping up these little hairs that are attached to sensors than if there were no hair on our skin whatsoever.
All right, so I think we've hit the worms and the grubs and the bugs. Let's hit our last three, which are honey, eggs, and milk, and let's take them in that order. Did our ancestors at any point eat honey? Do you think that was common? Is that a natural food for humans? Is it a bad food? Is it a food that, I know there's lots of issues with as far as animal concern regarding honey, but what would you say about honey?
Okay, all right. What I would say about that is the reason that I think most vegans are anti-honey is because of the abusive way commercial beekeepers produce their honey. They basically take all of the bees' honey and force them to eat like corn syrup, which eventually makes the bees sick and causes them to die. Honey is actually an incredibly powerful anti-infective agent, and of course it contains a lot of energy. So I do think that historically we did utilize and eat honey when we came across it. Now it's the fact is that bees are very good at hiding their nests and very aggressive about defending it. So it's not like we were having, honey like we have dessert every day. I mean, this would be a once in a while thing. And bees actually typically produce more honey than the colony will use. And so it is possible to take part of the honey and still leave enough for the bees to be okay. And I think that's what happened, that people would be out foraging, they saw a bee colony, and they would run in and grab a couple combs before the stinging got too bad, and then they would run away. And I mentioned yesterday that bees and wasps typically will chase a threat for a radius of 200 meters around their nest, and they fly at about 20 miles an hour. Well, the fastest humans are roughly 18 to 22 miles an hour at top speed, and we can only keep that top speed up for about 150 to 200 meters.
You're talking sprinting. You're talking like sprinting.
Sprinting, exactly. So our ability to sprint was not designed to chase anything down, because everything other than a three-toed sloth is much faster than we are. Nor was it designed to help us escape from predators, because lions, which are ambush predators, can keep up their top speed and will typically chase an animal for 300 meters. Wolves will actually go significantly further than that. So my point is that we are not fast enough to escape a lion or a wolf, and we're not fast enough to chase down an antelope or a deer, but we are fast enough to basically take ourselves out of the danger zone from a nest of stinging insects.
All right, so let's move on to eggs.
Eggs. Okay.
And one of the things I often think about is in the Midwest, the northern North America, I guess you'd say, there's a species of bear called the black bear. And the black bear, even though it's got carnivore teeth and it must have
it's an omnivore, yeah.
Right, but it never hunts, actually. It never hunts fish, it doesn't chase squirrels, it doesn't chase raccoons, it doesn't do anything like that. I don't even think, I mean, maybe it scavenges a little bit, but there's not that many dead carcasses. But it does, my understanding is that it'll like go for grubs and eat mushrooms, and it'll eat eggs and stuff. So eggs, in our evolutionary past, our historical past, how much of a contribution were eggs to our diet? I mean, I can't really imagine sucking down an egg,
right,
without it being cooked, and I don't particularly care for them.
But then again, you're not starving.
Right. Yeah.
So when you get a chance, I want you to take a look at that chart I showed you with the leucine content of various foods. Eggs are basically designed to create baby birds. So eggs are loaded with leucine.
Now, what is
and for that?
I think
leucine is an essential amino acid.
Okay, but we can get that from other places.
Oh, again, when you look at that chart again, you'll see that the plant foods have enough for our maintenance purposes, but not enough to actually turn on growth genes. Well, the reason the eggs have to have a lot in there is because you've got a creature that's growing in there, and it needs a lot of leucine. Eggs have been shown to be associated with a variety of diseases, including prostate cancer, colon cancer, other diseases. And again, it's because all of that animal protein, which is what eggs are, will turn on growth genes in us and start abnormally stimulating our genes, and will eventually lead to disease. Now, so for that reason, and now, so the question is, early humans, if they came across a bird's nest and the birds weren't too vigorous and trying to defend the nest, would they take advantage of the eggs that were there? Probably. But number one, remember, in nature, birds only lay eggs once a year. They're not like chickens. These chickens we selected for that lay eggs every day. Birds lay eggs in the spring, and they typically turn into the little baby birds, and they grow up and fly away. And so at best, it was seasonal. But the other thing about birds is that one of the reasons they are very successful group of animals is because they're very good at putting their nests in places where people can't, animals can't get to them. And so again, at best, our utilization of birds' eggs was seasonal and rare because it was only when we could access those nests. And I mean, one of the things I find really interesting is that during the winter, when the trees have all lost their leaves, is to look at how high up and how far out on those flimsy branches those nests are. No, the human beings who tried to climb up and get those probably didn't leave anybody to carry on their gene pool.
So what I'm hearing is there was probably not very much, if any, evolutionary pressure to become either honey or eggs for that to be like an essential food.
No.
And so our physiology is not like adapted to eggs or honey or anything like that.
Not at all. And the fact that studies show that when we eat eggs on a regular basis, it creates disease.
All right. So the last one is milk, dairy. And I have to tell you right now, this is a weird topic. I mean, already, again, we're 2020, April the 22nd, and so we're seeing things going on in the slaughterhouses where people are getting sick and the slaughterhouses are being closed down. And then on the dairies, the milk, which is being taken out every single day, and it's going to the packagers, but the packagers can't package it right because there's all this dislocation of where it's supposed to go. But then there's all these people, I mean, so many people, I mean, I don't know, 90% of the people in the US, 80% who have dairy products on a daily basis or something.
Right.
But isn't that normal, Milton? Isn't it just normal? Isn't it healthy? Shouldn't we get calcium that way? Isn't milk the right thing? I mean, when we're babies, we eat milk. Why shouldn't we have milk now? And cow's milk, oh, that must be even better I'm not sure why, but tell us about milk. I mean, aren't we evolved to eat milk as adults? I mean, what's the story here?
All right.
I mean, it's got to be healthy, right? I mean, we give it to our kids, right? I mean, we're told
it's only healthy.
In our schools, we have to give it to the kids, in order to get their plate of food for free and reduced lunch, they have to have their milk on there.
Yes, they do. And that's all marketing. And so people can make money off our children, not because it's good for them. It actually creates all kinds of disease. Okay. Here's another chart I want you to see. Can you see that?
Yes, great.
Up top, there are the carnivores. And you can see that even amongst the carnivore, every species, their milk is somewhat different. Now, in general, carnivore milk has a lot more fat and a lot more protein than the two herbivores down at the bottom. And that's because carnivores have very immature fetuses that essentially complete their development outside the womb. So you look at the amount of fat that's in the dogs or the wolf or the coyote, the black bear, so on. All these carnivores, their milks are loaded with fat and protein because proteins are building blocks. So you only need a lot of protein if you're growing really, really fast. So let me ask you, what is the slowest growing animal on the face of the earth in terms of
it's got to be the human
adulthood?
Because we have to take care of our children until they're like, I mean, in wild humans, I guess probably till they're like 12 or 13, right? Before they can figure themselves.
Exactly. Human beings are the slowest growing species on the planet in terms of, again, birth to adulthood. It takes us 20 years to reach our maximum body size. No other animal, not even elephants, take that long to reach their full size. And as a result, human milk has the lowest protein content of any mammalian milk on the planet. Because again, proteins are building blocks. You only need a lot of building blocks if you're building fast. If you're building slowly, you don't need a lot of protein. Now, look at the cow's milk and the human milk, which are both herbivores. And when you look at the amount of fat that's in the cow's milk versus the human milk, it's about the same, right? You see that?
Yeah, they look right next to each other on your chart there.
Right, but I mean, can you actually see the numbers?
Yeah, 3.6 and 3.7.
Exactly, so it's essentially the same amount of fat. Now look at the amount of protein.
3.2 for cows and 1.2 for humans.
So they have significantly more protein than humans, but that's because a cow goes from birth to adult size, if it's allowed to live, in 3 years. So they're growing much faster than human babies. But now look at the amount of sugar.
It looks like 4.7 for the cows and 6.8 for the humans.
So human milk has a lot more sugar. Care to hazard a guess as to why?
Our big brains, maybe?
Exactly. That's exactly it. That proportionately, the human baby has a gigantic brain, and it needs sugar. And in fact, when people feed their baby cow's milk, they are partially starving its brain. So but the point I wanted people to see, and when they have more time to look at that chart, what you'll see is that each species, the milks are different. I mean, they're the broad differences between the carnivores and herbivores, but even within each group, the carnivores, their milks are different in terms of how much fat, how much protein, and then when you actually look at the proteins themselves are different. And that's because milk is a fluid that is created by the female of a species that is targeted to her infant. The fact is that if you try to, let's say you had a dog, and right about the time that you and your wife were having just had a new baby, and the dog delivered puppies, but for some reason she died. Do you realize if you tried to raise those puppies on let's say your wife said, you know what, honey, I'm just going to express enough milk, pump enough milk to feed these puppies as well as our new baby. The puppies would die. They would die because there's not enough protein, and there's not enough fat, and there's not the right kind of protein in human milk to support the development of a puppy, which is a carnivore. And so the point that I'm trying to make is that milks are species specific. And again, when you go back to that leucine chart, you see that milk is loaded with leucine, and leucine is going to turn on growth genes. That's, well, again, it's okay for infant mammals, but it should not be ingested by adults. And is there any evidence to support that? Yeah. Milk has been shown to be the leading risk factor for developing prostate cancer. It increases the risk for breast cancer, ovarian and uterine cancer, and testicular cancer, as well as colon cancer. It's because milks are loaded with growth-promoting hormones and growth-promoting proteins. And they should only be ingested by infants. And the fact that, we've decided to utilize them to make yogurt and ice cream is, that's our fault. I tell people that, drinking milk is like smoking meth. You can do it for fun or because you like it, but you can't say it's a health behavior, because it's not. It's not healthy for you.
I've never heard that analogy before, but I may remember that one.
Yeah. So, and then, in terms of even with the two plant-based species, the cow and the human, although the amount of fat was essentially the same, 3.6, 3.7, the kind of fat is completely different. I know you've seen your wife's milk when she was nursing your sons, and human milk is almost translucent. That's because the fat that's in human milk is unsaturated fat, and which is why you can't make ice cream or butter from human milk. Whereas the fat that's in cow's milk is almost all saturated, which is why you can churn butter from it or make ice cream. So even though you have two herbivores, again, their milks are very, very different. And even the proteins that are in cow's milk, the casein, VSA, are very different from the proteins that are in human milk. And that's why they can cause allergy reactions and asthma, sinusitis, and all these problems in children who are being fed cow's milk. Human beings should not be ingesting cow's milk or anything made from cow's milk.
So apparently domesticated of milk-giving animals was like 10 to 15,000 years ago. And prior to that, you're saying
it's 6 to 10,000, yeah.
Okay.
That's for dairying, yeah, the practice.
So you're saying prior to that, humans just they didn't drink milk at all, and like there was really no way they could have adapted to milk being part of their diet. So human physiology is not milk drinking physiology as an adult.
With one caveat. So the practice of dairying, that is using other animals for their milk and making various products from their milk, as I said, estimates are 6 to 10,000 years old. What we have seen in the Northern European countries where dairying became a societal norm and cultural habit is that those people did adapt to consuming dairy foods. How did they adapt? Almost all mammals the sugar that's in milk, mammalian milk, it's called lactose. Lactose is what's called a disaccharide. It's two sugar molecules joined together. Well, the only way you can absorb that is if you split those two sugar molecules into their individual amino acids. And that's done by an enzyme called lactase. All mammalian babies have lactase when they're born. But most mammals, humans, gorillas, antelope, squirrels, you name it, once the infant grows up and starts eating its normal diet, their body stops making lactase. So they can no longer digest milk sugar, which makes sense. You don't want to expend a lot of energy and cellular machinery creating this complex protein that you don't need. That's also true of human beings. 65 to 75% of the people around the globe are lactose intolerant. They stop making lactase when they're weaned.
Doesn't everybody around the world drink cow milk?
Absolutely not. That is a phenomenon of certain Western cultures and a couple of East African tribes who are herders. The vast majority of people around the world do not utilize, historically did not utilize dairy products. Now, because of globalization and the penetrance of Western habits and dietary habits, more people have adopted cheese and people associate Mexican food with cheese, right? That's actually that's a post-colonization phenomenon. Indigenous Hispanic culture prior to the arrival of Europeans did not utilize dairy. Same thing is true of West Africans, which is why in this country, 75% of African Americans are lactose intolerant. Now you compare that to West Africa, and about 95 to 99% of the West Africans are lactose intolerant. And I give you 3 guesses as to what happened to African Americans.
As far as
why our prevalence is only 75% compared to our native land where it's closer to 95, 99%. It's the same reason you have light-skinned Black people. So
that's what I was kind of getting to, because I mean, the evolutionary pressure for my ancestors who were in Northern Europe, whatever, was to have lighter and lighter and lighter skin so that we could get our vitamin D. And so there was pressure in that direction. So thus I have lighter skin than you do. So it's
basically it's because of the slave owners raping the female slaves. And so you have significant penetrance of European genes into the African-American population, which is why you have a lot of light-skinned Black people.
So you're saying in the United States, there are some African-Americans that are more, that are that make the lactase in their
Yeah,
bodies.
they're roughly 20 to 25% can
And
drink milk and get away with it.
and
And that's because they've acquired this lactase persistent gene from their European great grand, I don't want to say grandparents because that wasn't a parental thing to do.
I get your point.
Genetic donors, yes.
Yeah. Well, my heritage is all over the place too. So,
Yeah.
That's really interesting. I guess I'd never considered that idea. Wow. So for milk, well, let's wrap this up with
So milk is filled with hormones, which again, recent studies showed that women who drink 3 or more glasses of milk a day. Well, you know what? Actually, let me make sure I'm quoting this properly, and I can bring this up really quickly.
Sure. And I think this is the reason that I knew you were the right person to call about this, because I've seen your talks. For people that don't know, I go and I help out. I volunteer for the vegan Summerfest by video recording their talks. And so I get to go in and see a lot of these talks, and Milton's talks over the years have always been very interesting because I love the idea of understanding ourselves from our ancestors, because our bodies are the result of, all this evolutionary pressure. But go ahead with your milk.
So basically, this is a study that came out, I think, this year. It included 53,000 North American women. It was conducted over an 8-year period. It's published in the International Journal of Epidemiology. And what it showed was consuming as little as 1/4 to 1/3 cup of milk per day was associated with an increased breast cancer risk of 30%. If you went up to 1 cup per day, that risk of breast cancer increased by 50%. And for those women drinking 2 to 3 cups per day, the risk increased 70 to 80%. So women, men, children, nobody should be drinking cow's milk. It's meant for cows. And all of those hormones and growth, the growth stimulating hormones in milk will basically stimulate our genes to do things that they shouldn't be doing, and ultimately it will result in disease.
Okay, so now we're going to bring it all the way back to a big, immediate answer to the big question. Again, April 22nd, 2020, here we are. People are out of work. People are told to stay home. Some people have to go, essential workers. There's a lot of people who's, low income. We'll just say low income.
Mm-hmm.
What, Milton, when they go to the grocery store, what should they be buying and what should they not be buying?
Okay, very good question. Because I think that our best bet for everyone with respect to this COVID-19 coronavirus infection is to maximize the health of our immune system so we can fight this thing off, as opposed to try and get over it once we get it. Now, again, if you have already been exposed, then you also want to maximize the healthfulness of your immune system so it can, help you fight this thing off. So what are the foods that enhance immune function? They are foods that are colorful. So,
like Fruit Loops.
No. Actually, thank you for that, Aaron.
Skittles,
no,
right?
Yeah. Oh my God.
M&Ms.
Lord have mercy.
It's got to be M&Ms.
I'm about to have a seizure. Yeah. No. Natural foods that are colorful. You absolutely want to stay away from processed foods like Skittles and Fruit Loops and anything made with refined flour or refined sugar or that has a lot of added oil, because all of those things in various ways detract from our immune system being able to do its job. One of the very interesting ways that sugar does it is sugar, as we discussed earlier, is fuel. It's a reactive fuel, and our body needs to keep our blood sugar level within the normal range, because as it gets too high, you see the damage that people who have diabetes ultimately end up with, damage to their heart, to their kidneys, to their lower legs, and so forth. So when people start to eat a lot of refined carbohydrates, the pancreas senses that and dumps out a hormone called insulin that tells the cells in the body, take up this blood sugar so that we can bring the blood sugar level back down to normal, okay? Well, our immune cells get that signal too. And so instead of them policing our body for, viruses or cancer cells or bacteria, they're so busy loading up on sugar under the influence of the hormone insulin that they aren't able to do their jobs. They're like cops in a donut shop. They are, basically drunk on sugar and unable to do their job adequately in terms of protecting us from potentially bad actors. So you definitely want to stay away from refined foods. I've mentioned several times that animal tissue, and that's meat, that's beef, lamb, pork, fish, poultry, sea animals, I refuse to call them seafood. All animal tissue will have a deleterious effect on our immune function. And
meaning a bad effect.
A bad effect, yes. And there are a number of reasons for that I can't go into. So you want to stay away from that. What improves immune function? As I said, colorful, whole plant foods and fruits and vegetables. So you want to eat your green vegetables. You want to eat things that are orange and yellow and red, particularly red and purple. Berries are absolute powerhouses in terms of their antioxidant and beneficial plant compound content. So, a mixture of berries, strawberries, blueberries, blackberries, raspberries, and cranberries. But again, the key is variety. The greater variety, the better. So you want to do your green leafy vegetables. And I cannot emphasize this enough. Legumes are essential nutrients for human beings.
Okay, give me a handful of examples of legumes.
Okay, so what is a legume?
That's just not a word I ever use.
Right. Legumes are beans, peas, and lentils. So those are the seeds of these plants. So and in all kinds of beans are great. Black-eyed peas, pinto beans, black beans, Great Northern, lima beans. And then there's a whole slew of other beans that I don't even know the name of. There are hundreds of different kinds of beans, garbanzo beans. Eat a wide variety of beans. You want to include beans in your diet at least 3 times a week, okay, at one or more meals 3 times a week. And beans have a amino acid. They have high content of amino acid called cysteine, which helps boost immune function. And beans are very high in protein. You eat your beans. They completely take the place of animal tissue and animal products. Again, your citrus fruits are really healthy. Now, in terms of specifically warding off coronavirus, there were some studies that were done in China early on in the epidemic where they did autopsy studies on people who died from the disease. And what they found was that many of them had subnormal levels of a mineral called selenium. And selenium is very important for immune function. And so you want to make sure that you are getting an adequate source of selenium. Now, that sounds hard because the selenium is a weird sounding word. It's a mineral. It's like, what do I have to do? Do I have to drive across town to, some weird store? No. Get yourself some Brazil nuts. Brazil nuts are the highest source of selenium in the American diet, and literally 3 Brazil nuts a week will keep your body selenium replete. You want to, again, do the brightly colored fruits and vegetables because they have a compound in them called quercetin. And a European country did, they actually did a study looking at supplemental quercetin, and it showed activity against coronavirus. You want to make sure you're getting a good source of zinc. Probably the easiest way to do that is to just take a supplement every other day, and in the setting of a whole food plant-based diet. But again, avoid foods that are high in fat, that interferes with immune cell function. Avoid foods that are high in refined carbohydrates, like white flour, white rice, white sugar, and so forth. And avoid animal products like animal tissue and dairy products. There are all sorts of plant milks out now that are delicious and can be used any way that you would normally use. Excuse me, dairy, cow's milk in cooking and so forth. And so there is no need whatsoever to use dairy products because they are very unhealthy. And for people who say that they miss ice cream, I'm going to insist that as soon as you finish listening to this podcast, you go to your local store, observe the appropriate distancing and wear your mask, but look for Magnum brand non-dairy ice cream bars. They're non-dairy vanilla ice cream and dark chocolate. And I'm telling you, you will not be able to tell the difference. Now, that's not something you should have every day, but I'm just saying for a once in a while treat, you can have a non-dairy ice cream and you will not be able to tell the difference.
So I would put that in the category as that's the honey, and you're going to get it once in a while. Rarely,
once in a while. Only once in a while.
High glycemic load, but once in a while, we can do that. So as far as for people who are like really low income, I know that a lot of times produce is not that inexpensive, especially fruits.
Sure.
But I would say, are you suggesting also like pinto beans or peanut butter or whole oats or whole rice or lentils?
Right. Your dried grains, your dried beans and dried grains are some of the cheapest foods that you can get, and they will last forever. So that's like you want to get whole grain rice, and you know, so that's brown rice, but it's also wild rice. There's red rice. There's a whole slew of different types of rice. And again, the greater the variety, the healthier the diet. And then, as we said before, there are literally hundreds of different kinds of beans. If you go on YouTube and type in my name, Dr. Milton Mills, and then put protein, I have a lecture all about protein and where to find protein. At the end of that lecture, I list the protein content of probably about 20 or 30 different types of beans and also nuts. You want to try to include a quarter cup of walnuts in your diet a couple times a week. Now, that does not mean you have to sit there and eat walnuts out the cup. You can chop them up and mix them in with your oatmeal. You can put them in casseroles. But so there's lots of ways that you can eat walnuts, but walnuts.
Is that the same for all, because walnut nuts are like a tree nut, right? Is
yes.
that the same for all tree nuts then?
No, actually, no. And that's really interesting. Well, let me say this. I think all tree nuts are good, okay? But they do different things. But walnuts have been shown to have amazing properties in terms of anti-cancer properties, helping to improve memory and cognition and ward off dementia, and also helping to improve muscle function and movement.
Because peanuts are like a tuber or something, which is like a different kind.
Yeah, peanuts are actually a legume.
A legume, okay.
Yeah, but let me I gotta show you. By the way, many of these slides that I'm showing you are from this new lecture I've done on cancer. And I'm not sure how well you can see this, but this is let's see, these are colon cancer cells. And this looks at the growth of those cells versus a given amount of nuts. And you can see the most potent nuts for slowing the growth of the colon cancer cells were walnuts and pecans, followed by peanuts. Then come almonds, and those I think are pine nuts. Out here,
Macadamia.
yeah, yes, and so forth. And then you got water at the top just to show you that I didn't do anything. Now, for colon cancer cells, it looks like cashews don't do a whole lot, and a couple of other nuts don't seem to be that potent. But look at this. Oh, you know what? I'm sorry.
No, that's all right.
This is okay.
Well, that's really interesting. I mean, Milton, it almost seems like you're suggesting that if someone is concerned about having cancer, getting cancer, if they have a loved one with cancer,
they should stop eating animal foods immediately. Now, this looks at liver cells. And again, the clear winners here are walnuts and pecans, but you can see cashews did a bit better. Almonds were okay. Whereas the macadamia nuts and some of those didn't do much. So the point is, different plant foods all have different beneficial properties, which is why variety is the best thing that we can do in our diet. We shouldn't just say, oh, I'm going to eat nothing but, walnuts, or I'm not going to eat anything but this. No. Variety is just like, look at the universe, look at our solar system. I believe in God. So I say God created with variety, because variety improves the quality of life. And the same thing is true of our diet.
All right, so I think we have about 3 last things. First thing is there anything from this conversation that we've been having that we kind of skipped, I forgot to ask about, we kind of really missed this big idea?
No, I think that our conversation today was even more thorough and complete than yesterday. And, Aaron, obviously we could, I love your mind, because you take a very sort of intellectual approach to things, and I could talk to you like till this time tomorrow. But I think we did hit the major points, and certainly the things that we talked about yesterday.
Now, if people are watching this, or how can they learn more about this important stuff, especially from you?
Sure. So there are 2 ways. You can go to YouTube and type in Dr. Milton Mills, and a whole slew of lectures will come up, including our Humans Designed to Eat Meat, Meeting and Mind Games, Protein, Diabetes. There's a bunch of them. And or you can go to my webpage, which the title is kind of long, but it's not that complicated. So it's just Dr. Milton Mills, plantbasednation.com. So that's Milton Mills, plantbasednation.com. And that has a lot of information and various posts on various health topics, and also links to most of my lectures as well.
Okay, and I'm pulling that up, and I'm going to show that on the screen.
Oh, cool.
Just to make sure that anybody viewing it can have a look at it, because that is a long domain name you've got there. Okay, should be able to see that there. So Dr. Milton Mills, plantbasednation.com. And I bet if you just go to Google, you can probably just type Dr. Milton Mills.
Yeah, there. Let's see. Well.
So there's a lot of links, but it doesn't link right to your.
I'm gonna have to get that figured out. Yeah.
Yeah, but you've got, okay, so that's good. Dr. Milton Mills, Plant-Based Nation, no hyphens, no capitals, nothing, just all one word. All right, great.
And I know it was long, but I wanted to make that point. We need to become a plant-based nation.
Excellent. All right, so I would like to thank you, first of all, Milton. It's been a great pleasure.
I've enjoyed this as well, Aaron. Thanks for inviting me.
And I'd like to thank everybody who's viewed. If you have appreciated this content, if you think it is worthwhile in any way at all, please let me know by subscribing and by ringing the bell so you get notifications for future videos, by putting a comment or a question in the comment box, by liking, by sharing, if you can share it with anybody, anyone you love, anyone you think this would be helpful for. And look forward to future videos. You can also look to previous videos, which were on not just nutrition topics, but different topics. There is a video with nutritionist Julie
Oh, Juliana, yes.
Heaver, which I just recorded and published yesterday along with her partner. And and there's lots of this information online. You can find this if you look for it. Look under plant-based eating or vegan nutrition, and anywhere you look, there's lots of information. And so thank you very much, everybody, for viewing. This has been Aaron Wissner of Local Future, Milton Mills, MD, and we hope you take care of yourself, take care of one another, and eat healthy in this trying time that we are.
Absolutely. All right, take care, Aaron.
Take care, Milton.
All right.